listen to me. Listen closely to me.
The idea of matter being made up of small indivisible particles was first put forward in ancient India and then shortly after in ancient Greece, about 400 or 600 BC. It was not until 1896 that J.J. Thomson investigated the fundamental nature of the electron, developed further by Rutherford in his explanation of alpha particle scattering, that the idea of a divisible atom was accepted. The visual aids that we use of a nucleus of protons and neutrons surrounded by electrons are just that. We have no way of knowing exactly what an atom looks like. We cannot resolve it with any kind of microscope. Nevertheless, research makes us fairly sure of the properties of these particles. Protons, we think, have a mass of 1, as have neutrons. Electrons are far lighter, with a mass of about 1/2000th of a proton or neutron. These measurements are made in atomic mass units, that is on a scale where the most common type of carbon atom is given a mass of 12. Overall, individual atoms are electrically neutral, but within that, protons have a positive charge of 1 and electrons have a negative charge, that is a charge of -1. Because there are the same number of protons and electrons, the charges cancel out. Neutrons have no charge at all. The diagram we've used here shows 4 protons and 4 electrons. Let's identify that atom inside the periodic table. It's beryllium. We would write the symbol and structure of beryllium like this. The number 4 is the proton number, and the number 9 is the nucleon number, that is the number of particles in the nucleus. Beryllium therefore has 4 protons and an equal number, that is 4 electrons. The number of neutrons is the nucleon number minus the number of protons in the nucleus, so it's 9 minus 4, which is 5 neutrons. Suppose we had a version of beryllium with a nucleon number of 8. It would still have 4 protons and 4 electrons, but now 8 minus 4, which is 4 neutrons. These two versions of the same element are called isotopes. All elements have isotopes, and some have many. Isotopes of an element must have the same number of protons, but they have a different number of neutrons. This has absolutely no effect on its chemical properties. Here are 3 known isotopes of carbon. Carbon-12 is stable and the most common isotope. Carbon-13 is stable but has 1 more neutron. Carbon-14 is unstable, it's radioactive, and has 2 more neutrons than carbon-12, which is the most common. Supporting notes for this video are available on the website. Thank you for watching.